Hello everyone, this is Mr. Richard Iglesias, your mathematics teacher for this session. In this video lesson, we will learn how to find the domain and range of exponential function. Come with me as we go through this lesson. Let's begin. Start with, here are the lesson objectives for this video lesson. After going through this lesson, the students are expected to, number 1, define domain and range. Number 2, find the domain and range of a given function. And number 3, represent the domain and range using the set builder and interval notation. To help us recall, let us find the domain and range of the given function. Find the domain and range of the function y is equal to 2x plus 3. To find the domain and range, we simply solve the equation y is equal to f of x to determine the values of the independent variable x and obtain the domain. So for our solution, since the function is a linear function, any real number can be substituted to x to get an output. So here are the sample values for x. If x is equal to 3, we can get y is equal to 9. If x is equal to negative 2, we can get y is equal to negative 1. Therefore, the domain and range are all real numbers. You can express your answer in the set notation or interval notation. Domain is the set of x values such that x is the set of all real numbers, or in interval notation, that is negative infinity up to positive infinity. For the range, it is the set of y values such that y is the set of all real numbers, or on the interval notation, that is negative infinity up to positive infinity. Let us now proceed to the definition of the domain and range. The domain of a function is the set of all allowable values of x, commonly known as the independent variable or possible inputs of the function. The domain is also known as the independent variable, or sometimes refers to as the input, while the range of a function is the set of output values, commonly known as the dependent variable, when all x values in the domain are evaluated into the function. If the domain is the independent variable, the range is the dependent variable. Also, if the domain is the input, the range is the output. This means that you need to find the domain first to describe the range. Let us now have the key concept for this lesson. Domain and range of exponential function. Let f of x equals a times b raised to p of x plus h be an exponential function where p of x is linear. In cases of exponential functions where p of x is linear, in which case b raised to p of x will always be defined for any values of x. Thus, the domain of an exponential function is the set of real numbers. For the domain, the set of x values such that x is the set of all real numbers, or in interval notation, that is from negative infinity up to positive infinity. For the range, note that b raised to p of x is greater than 0 for any values of x. Hence, the range of an exponential function will depend on the values of a and h. If a is greater than 0, the range is the set of all values such that y is the set of real numbers, wherein y is greater than h, or in interval notation, that is from h up to positive infinity, where h is not included in the solution. If a is less than 0, the range is the set of all values such that y is the set of real numbers where y is less than h, or in interval notation, that is from negative infinity up to h, where h is not included in the solution. And these are the basic concepts in order for us to find the domain and range of an exponential function. So let's now proceed with the examples. For our first example, we have f of x is equal to 5 raised to x. So how can we find the domain and range of the given function? To start with, let's identify first the values of a, b, p of x, and h. So we have a is equal to 1, b is equal to 5, p of x is equal to x, and h is equal to 0. Since we already have the values, let us now find the domain and range. The function f of x is equal to 5x is defined for all real numbers. So the domain of the function is the set of real numbers. So we have domain is the set of x values such that x is the set of real numbers. And to write this up in interval notation, we have negative infinity up to positive infinity. So take note of that. To find the range, let us check the values of a and h, since we said earlier that the range depends on the values of a and h. Since a is equal to 1, then a is greater than 0. So we have the range is the set of y values such that y is the set of real numbers wherein y is greater than 0, or in interval notation, that is from 0 up to positive infinity. Next is example number 2. We have f of x is equal to negative 1/2 raised to x. For our solution, let's find the values of a, b, p of x, and h. So the value of a is negative 1, b is equal to 1/2, p of x is equal to x, and h is equal to 0. Since we already have the values, let us find the domain and range. Always remember that the domain of exponential function is the set of all real numbers. So the domain is the set of x values such that x is the set of real numbers. And to write this up in interval notation, we have negative infinity up to positive infinity. To find the range, let's check the values of a and h. So since the values of a is equal to negative 1, then a is less than 0. So we have the range is the set of y values such that y is the set of real numbers wherein y is less than 0, or in interval notation, that is from negative infinity up to 0. For our third example, we have f of x is equal to 2 raised to x plus 1 minus 7. So for our solution, we're going to find the values of a, b, p of x, and h. A is equal to 1, b is equal to 2, p of x is equal to x plus 1, and h is equal to negative 7. For our domain, we have the values of x such that x is the set of real numbers, wherein if we are going to write this in the interval notation, we have the negative infinity up to positive infinity. To find the value of range, let us check the values of a and h. So we have a is equal to 1, then a is greater than 0. So the range is the set of y values such that y is the set of real numbers wherein y is greater than negative 7. Or, in interval notation, that is from negative 7 up to positive infinity. So these are the examples of finding the domain and range of the exponential function. I hope that you have learned something from our discussion. That is all. Thank you everyone. Thank you for tuning in.